These are the notes for the Bohr model. Basically, in the Bohr model, what we're going to do is represent an atom, and we're going to write down how many protons and neutrons are in the nucleus of the atom, but then we're also going to show how many electrons are in the atom and show what levels they're at, because electrons surround the nucleus at predetermined energy levels, or we call these shells. And so if this is the nucleus right here in the middle, we have a first shell, a second shell, and a third shell that the electrons can reside in. And the number of electrons in each shell is determined by how many can be held in that shell. So the first shell closest to the nucleus can hold up to 2 electrons, and then the next shell can hold up to 8, and the third shell can also hold up to 8. And what happens is each of these shells is filled, and then once that is filled, then the next shell starts to become filled with electrons. So we're going to show that with 3 examples real quick. Here we have a helium atom with a mass number of 4, and so we need to first determine how many protons, neutrons, and electrons are in the helium atom. If we go and find helium, which has a symbol of He, that's in the top right-hand corner of our periodic table, and the atomic number at the top of that cell, which is 2, tells us how many protons are in the helium atom. So we have 2 protons, and then to find the number of neutrons, we're going to take the mass number of 4 minus the number of protons, which is 2, and we get that there are going to be 2 neutrons. And then for electrons, we're going to have them be equal to the protons. So we have 2 protons, 2 neutrons, and 2 electrons. For the protons and the neutrons, we're going to write this in the center of our Bohr model. And so if I zoom in a little bit here, we're going to write down 2p for 2 protons and 2n for 2 neutrons. And then for electrons, we're going to need 2 electrons. And since the first shell can hold 2, we're going to put them both on the first shell. Now, when you're drawing electrons, we want to draw them as far apart from each other as possible. We don't want them to be like cramped up together, for example, like this, because electrons are the same charge as one another, and that makes them repel. So I'll redraw down here. This Bohr model is finished because there are 2 electrons, which are all of the electrons, and they're both on the first shell. For our second example, we have beryllium-9. And beryllium, we can look, it has the symbol of Be, and so we'll find it right here. And if we zoom in, we can see that the atomic number is 4, and then the mass number for this one is 9 based on how it's written. So because the mass number is 4, that tells us the number of protons. And then to solve for the number of neutrons, we're going to do the mass number of 9 minus that proton number of 4 to get 5 neutrons. The electrons and the protons are going to be equal today, so that is 4. And so the way that we're going to show or complete the Bohr model is we're going to write down 4p for protons and 5n for neutrons. Notice that 4 and 5 add up to our mass number of 9. And then we're going to start drawing electrons. Now this atom needs 4 electrons, and so I'm going to draw 1, 2 electrons, but I can't put the third or the fourth electron on this first shell because the capacity of this first shell is only 2. And so then what I'm going to have to do is I'm going to put the third electron and the fourth electron on the next shell outside of the first one because the first one is already filled up. For our last example, we have silicon. Silicon we can find with the symbol Si, which I believe is right here. It has an atomic number of 14, and so we are going to write down 14 protons and 14 electrons since they are balanced. Then for number of neutrons, we're going to take the mass number of 28, and we're going to subtract the number of protons to get the number of neutrons, which is also 14. I apologize for those notifications. Now to complete the Bohr model, we're going to write down 14 protons and 14 neutrons in the center. That's where the nucleus of the atom would be. And now we have 14 electrons. So I'm going to put the first two on the first shell, but then the third one I can't put on that shell. So I'm going to put 3, 4, 5, 6, 7, 8, 9, 10. And once I get to 10, now this second shell is also filled. So remember that the first shell can hold 2, the second shell can hold 8, and the third shell can hold 8. And so at this point, we filled the first shell, we filled the second shell, and together that is 10 electrons, but we need 14. So we need the rest of the electrons to go on this last shell. And so since we have 14 total electrons, we already placed 10. We only need 4 more. We're going to put those 4 on the last shell. 1, 2, 3, and 4. And now our Bohr model is complete for silicon 28. Thank you for watching.